Most of the fat you lose does not leave through sweat or the toilet. It leaves through your lungs. Before that can happen, stored fat must be dismantled molecule by molecule, transported through your bloodstream, and fed into microscopic furnaces inside your cells. But burning fat is not the same as losing body fat, and that difference explains why so many diets fail. After you eat, carbohydrates are broken down into glucose. As glucose enters your blood, the pancreas releases insulin. This hormone helps cells use glucose and tells the liver and muscles to store some of it as glycogen. If more energy arrives than your body immediately needs, some can be stored in fat cells as triglycerides. Insulin is not your enemy. It is an essential control signal. But while insulin is elevated, it strongly suppresses the release of stored fat. Your body already has incoming fuel, so it has less reason to open its energy reserves. Then, the situation changes. Several hours pass without food, or your muscles begin demanding more energy. Insulin generally falls, while signals including adrenaline and noradrenaline can encourage fat cells to release fuel. This is where the transformation begins. Inside each fat cell, enzymes attack a stored triglyceride and split it into glycerol and 3 fatty acids. The glycerol can travel to the liver. The fatty acids enter the blood attached to transport proteins and are delivered to tissues such as muscle, heart, and liver. But the fat has not been burned yet. It has only been released. To produce usable energy, fatty acids must enter cells and reach their mitochondria. Long fatty acids pass through a controlled gateway before a process called beta-oxidation cuts them into smaller units. These become acetyl-CoA, enter the citric acid cycle, and help drive the production of ATP, the energy currency that powers your cells. And here is the part most people never see. When stored fat is fully oxidized, much of its carbon ultimately leaves your body as carbon dioxide through your lungs. The rest contributes largely to water. Fat does not simply turn into heat or sweat. A large part of its mass leaves with your breath. This metabolic shift is not a switch that suddenly flips from sugar to fat. Your body normally burns a mixture of fuels. The balance changes from minute to minute depending on food, activity, hormones, fitness, sleep, and the energy your tissues require. At rest and during many lower-intensity activities, fat can supply a substantial share of energy. During harder efforts, the body often increases its reliance on carbohydrates because they can deliver energy rapidly. During longer periods with lower carbohydrate availability, the liver may also convert some fatty acids into ketone bodies. These can support tissues, including the brain. But ketosis is not required for your body to burn fat. Now comes the uncomfortable truth. Oxidizing more fat for an hour does not guarantee that you will finish the day with less body fat. A fasted workout may increase fat use during that session, but if the energy is replaced later, the net change can be small. Long-term fat loss requires the body to draw more energy from its stores than it deposits over time. This is also why the number on a scale can mislead you. Glycogen holds water. When glycogen falls, water weight can fall quickly, even before much fat has disappeared. When carbohydrates return, some of that water returns with them. The body can therefore become lighter without losing the same amount of fat, or burn fat temporarily without becoming lighter. And not all stored fat behaves identically. Subcutaneous fat lies beneath the skin. Visceral fat surrounds organs inside the abdomen and is more strongly associated with inflammatory signaling, insulin resistance, and cardiometabolic risk. Yet your body decides where fat is released according to genetics, hormones, and biology. You cannot command it to burn only one area. So what actually happens when your body starts burning fat? A chemical reserve is unlocked, broken apart, transported, pulled into mitochondria, and converted into cellular energy, carbon dioxide, and water. It is happening inside you every day, even while you sleep. The real transformation does not come from activating a secret fat-burning mode. It comes when this microscopic process, repeated over days and weeks, removes more energy from your fat cells than your body returns to them. Every molecule has to make that journey, and with every breath, part of that stored energy can quietly leave your body behind.